So this is my 32-bit ALU design for the Lab2. So it contains actually 5 functions and 4 devices. So the first one is a 32-bit add or subtractor, and another one is a shifter and 32-bit OR gate, and a 32-bit AND gate. So I will start describe this thing from the subtractor. So the 32-bit subtractor is built from a 32-bit adder plus one 32-bit XOR gate. So how this thing function is, this thing is actually a adder subtractor. So based on the carry in bit here, if the carry in is a 0, this thing is act as a 32-bit adder. If the say in is 1, this is a 32-bit subtractor. Just basically XOR the B input with the carry in. And so this is my how the 32-bit adder looks like. It contains four 8-bit adders, and this is how the 8-bit adder is built. It has two 4-bit adders, and this is the full adder. This is the like the 4-bit adder. It contains 4 full adders, and this is the full adder. And I have a built-in flip-flop for this one in order to make the schematic looks better. And the next one is the shifter. Shifter is relatively easy. It's just 16 flip-flop 32 flip-flops that shift the input to the right for 1 bit and add a 0 to the output for the output 0. And this is the 32-bit OR gate. It contains 8 input OR gate, and this is the OR 8 input OR gate, which contain 8 2 input OR gate, and this is the element in this OR 8, which contains 1 2 input OR gate and a D flip flop. And for the AND gate is similar, just change the AND gate OR gate to the AND gate, and it also has a built-in flip flop. And we can see the simulation for each of them. The first one is the 8-bit adder. So let's see. So we can see the result here. So the input A is FF, which is 255, and B is 0, and the result is correct. And for the next one, I have A0 and 0A as input, so the output is AA in hex. And so for the next one is like 255 input and 1 input, and also a 1 for the carry in. So which should have a overflow, and the carry out should be 1, and the result, the sum should be also 1. So which are all correct for this one. And the next simulation is for the shifter. Yeah, so this is the shifter. So as you can see, I have a A0 in hex input, and the output is 14140, which is correct. And a more easy one to understand this one is actually I have a 0505 as input, which should be a 080A if I have a right shift. And then is the 32-bit AND gate. So this is the result. So the first input is just 0 and FFFFF. And the result is actually 0 because it's an AND gate. And then it's a 0808 and with a 5050, which should be a 0 output here. And then it's just a OF and with 5050, and the result should be 5050 since it's an AND gate. And similar for the OR gate, we have the similar simulation. So it is easy to see the result here, and A0 or 0A is just AA in hex. And then is the simulation for the subtractor. So you can notice here the C in part is 1, which means it's act as a subtractor, and 3 minus 2 is just 1, which is correct. And here the C in is 0, which means this is an adder, and the input for 1 plus 3 is 4, which is correct. And also we have the map report here. So implementation map report. So here are the resources we used for this design schematic, and I have a screenshot here. So which is yeah map. So this is similar with this one, and then just let's go to full see the Verilog one. Okay, so this is how I implement the Verilog version of the ALU. And I do have a simulation for this one. Just this one. So yeah. So first, I just use the one hot code for the selection and 5-bit selection since we have 5 functions: plus, minus, subtract, and AND, or, and shifter. So as you can see here, so clock. So the first clock, I set the select to 1, which should be an adder, and the input are just A0 A0 and 0 A0 A. So if we add them up, we have all A's at the output. And the next one is the should be the subtractor. Yeah, subtractor, which is A minus B, which looks correct. And the third one is AND. So A0 A0 and with 0 A0 it should be a 0, all zeros. And the fourth one is OR, which A0 A0 or 0 A0 it should be all A's. And just let me run it for a little bit more to see oh, the last one, just a shifter. So you can see the select is just 1000, and it just like shift input A to the right, which is actually 505050, which is correct. Okay, and we can also see the um implementation map report for this one. Map report. So here's a map report resources used for the Verilog version of the ALU, and here's a use of the schematic version. So the flip-flop is pretty much similar, but the LUTs, we have lots of more LUTs used for the Verilog version. Yep, that's all my videos for the Lab 2.